All right, we had started this in the hopes of getting a little bit done in the last class, and then the bell rang. So one of the things that you're going to be asked to do is to find sine, cos, and tan of angles without your calculator that are related to your unit circle. But if I told you something like, what is cos of 3,720 degrees, how would you know that that was part of your 60-degree family? How would you know that it ends in quadrant 2? So that's what we're going to look at first. Where does an angle end? So if I have 4,300 and I have a calculator, I could divide by 360. And the fact that I got 11.94, does it make sense that this is halfway around the circle, this is a quarter of the way around the circle, and this is 3/4 around the circle? So if I went 11 full revolutions and then 0.94, that tells me that 4,300 is in quadrant 4. It does 11 full rotations and then almost another full rotation. Now, most of the time, you won't have a calculator for these questions. So if I didn't have a calculator for 4,300, I would probably start by subtracting 360 10 times, because that's easy mental math to see that that would be 3,600. If I subtracted it 10 times, I would get 700 degrees, which means that 4,300 degrees is coterminal or ends in the same place as 700 degrees. And if I subtracted 360 once more, I get 340 degrees. And 340 degrees is also coterminal then. And then I would be able to tell, oh, that's in quadrant 4. Because I know 340 would end in quadrant 4 because it's 360 degrees all the way around. So that's how you would do this question if you didn't have a calculator. You just keep adding or subtracting 360. Every time you add or subtract 360, you get another coterminal angle until you find one that you can be like, oh, I know where 340 is. It ends in quadrant 4. Computer is very, very fast today, as you can see. Oh, there we go. It's really happy when it goes gray. Yes, question? Oh, you're just putting your hand up. I totally understand. All right. Oh, there we go. One more one, we'll get to radians. And radians will be, oh, I went too far now. Now, radians will more often be something that is done without your calculator. The nice thing about radians is that if you got something like negative 23 pi over 6, and 23 over 6 doesn't reduce, it's already in lowest terms, you know right away that that's part of your pi over 6 family. So if I was asked, what sine of negative 23 pi over 6? Since I know sine of pi over 6 from my unit circle. Anybody have it? Is it 1/2 or root 3 over 2, sine of pi over 6? 1/2. So I would know that sine of negative 23 pi over 6 is also going to be 1/2, but I wouldn't know if it's positive or negative. I'd have to determine what quadrant it's in. So this is what this is trying to do for us right now, is figure out what quadrant is negative 23 pi over 6 in. And you know that this is 0. All the way around is 2 pi. Halfway around would be pi. Can you see that if I went all the way around once and then another one, this would be 3 pi? And then this would also be coterminal with 4 pi. And then this would be coterminal with 5 pi. and the coefficients here are always odd, and the coefficients here are always even. So if I take the 23 over 6 and change it to a mixed fraction, 23 is 3 and 5/6 pi, so negative 23 pi over 6 would be negative 3 and 5/6 pi. Now 3 is an odd number. I can visualize it. Here's 1 pi, here's negative 2 pi. Here would be negative 3 pi. It's going to end at the negative x-axis. And then if you went another 5/6, can you see that this is more than half? So if I went to negative 3 here and I went more than half, it's going to end in quadrant 1. So what we're really going to do for our radians is practice changing our numbers from improper fractions to mixed fractions and then using that to find the quadrant. So if I wanted to say what is sine of negative 23 pi over 6, I could now say it's positive a half because it ends in quadrant 1 and it's part of the pi over 6 family. Now I've got a sheet for you guys that I'm going to hand out now. We're going to do a couple of them together, and then the rest will be for you to practice on your own for homework. And I sent enough, Izzy, for your row down this one. So Josh, when it gets back to you, so we're going to do a couple of these together. Do you see that the very first one is 13 pi over 6? And so it's just going to ask, what quadrant is it in, and what is it coterminal with? So assignment 1, which as soon as my screen fast forwards 2 buttons, we'll be able to see it. But it's not responding. But assignment 1 says, state the quadrant it's in and say the first positive angle it's coterminal with. So if I had, there we go, there we went. If I had number 1, 13 pi over 6. Wow. Well, 13 pi over 6 as a mixed fraction is equal to 2 and 1/6 pi. I wonder if it still records my voice while the screen is frozen, or if I'm like, I don't know. Oh, there we go. I don't even know what to do anymore. I've been trying to get a new computer. They're working on it. I know. So 13 pi over 6 would you agree that that's, as a mixed fraction, would be 2 and 1/6 pi? Now, think about your unit circle. It's going to be part of 2 pi would be here, right? We're going in the positive direction, so you would be with the 2, you'd end at positive x-axis. Then 1/6 more is going to end in quadrant 1. What's your pi over 6 family in quadrant 1? It's going to be coterminal with pi over 6. The second example, what do you think? Do I dare? The second one, 19 pi over 6. Oh my goodness, look at that. 19 pi over 6. Can you see that that would be equal to 3 and 1/6 pi? 3 pi would be at the negative x-axis. 1/6 more, and which way are we traveling? Down, will be in quadrant 3. It's going to be coterminal with, what's your pi over 6 in quadrant 3? 7 pi over 6. Why is this helpful? Well, when you get to one like number 5, it has 101 pi over 4. 101 pi over 4 is 25 1/4, because 25 times 4 is 100, and you'd have 1/4 more. Can you see that 25 1/4 would be in quadrant? Well, 25 would be at the negative x-axis because it's odd. 1/4 more would land you in quadrant 3. And we could say that this is coterminal with, what's the pi over 4 in quadrant 3? 5 pi over 4. So assignment 1 on this sheet, because at the bottom it says there's 2 assignments. Assignment 1 just says to say what quadrant it's in and what it's coterminal with. That's assignment 1. And when you get to question number, for example, you get to question number 11. Let's do 11 together. For assignment 1, you just ignore the sign, 9 pi over 4. Can you see that 9 pi over 4 is 2 1/4 pi? That would be quadrant 1, coterminal. What's the pi over 4 family in quadrant 1? Just pi over 4. So that's assignment 1 on this sheet. Assignment 2, assignment 2 says for questions 1 to 8, write the coordinates. So in question number 1, in assignment 1, we determined this was in quadrant 1, part of the pi over 6 family. Quadrant 1, part of the pi over 6 family, the coordinates are √3 over 2, comma 1/2. So you can use your unit circle to help you with this right now. If you don't have it completely memorized, that you can just pull the answers out yet. You can have your unit circle off to the side and check them. So if I got to question number 5, remember question number 5, we figured out that that was in quadrant 3, our pi over 4 family. Our unit circle for pi over 4 is √2 over 2, √2 over 2, and since it's in quadrant 3, those would both be negative. Then once you get to question number 11, where it says sine of 9 pi over 4, we just want to evaluate that. Sine of 9 pi over 4, well, it's in quadrant 1, coterminal with pi over 4. It's √2 over 2. So that's what this paper is for practice. Done a couple of assignment 1 and assignment 2 for you. And so if you know your unit circle, you can now figure out the following values. Anytime you have a pi over 6, a pi over 3, a pi over 4, you should know the answer. And the strategy that I like to use is know quadrant 1, and then just know what quadrant it ends in. So for example, I know that 7 pi over 6 is in quadrant 3. I know that my pi over 6 family for sine is equal to 1/2. So 7 pi over 6 will equal to 1/2, but since sine is negative in quadrant 3, it has to be negative 1/2. So this is how your mind figures this out if you don't have your unit circle in front of you. Part B. Pi over 3 family for tan. I know that it's going to equal √3. And because it's in quadrant 2 and tan is negative in quadrant 2, I know it has to equal negative root 3. Seven pi over 4. I know for cos it's root 2 over 2. I know this is in quadrant 4. Cos is positive in quadrant 4. You don't have to write a positive sign, but just the fact that I'm checking it, that means it has to be positive root 2 over 2. When you get to ones like secant, cosecant, and cotangent, what you're going to do first is figure out what cos is. And notice the angles never change. So it'll still be the pi over 4 family. It will never be 4 over pi. You never change your angles when flipping between secant and cosine or cosecant and sine. But since I know that cos of my pi over 4 is root 2 over 2, and I know that negative pi over 4 is in quadrant 4, I can say that secant then is the flip of the answer, 2 over root 2. In your textbook, though, or on a multiple choice, sometimes they will rationalize. This is equal to root 2. Just like, do you remember that we originally, from our special triangle, had that equal to 1 over root 2? And actually, if you had 1 over root 2, flipping it to root 2 is even nicer, right? So to be able to switch back and forth and rationalize your denominator. So cotangent of 11 pi over 6. First, I would find tangent of negative 11 pi over 6. I would think about quadrant 1. Does anybody else use this strategy? I remember tangent of pi over 6 is root 3 over 3 because 3 plus 3 equals 6. That's how I remember it. And tangent of pi over 3 is root 3 because root 3 equals 3. Now, what quadrant is this? Negative 11 pi over 6 is going in the negative direction. It's in quadrant 1, so tangent should stay negative. It'd be quadrant 4 if it was positive 11 pi over 6. And that is actually a brilliant strategy for figuring out what quadrant it's in. 11 pi over 6, can you see if I start here and go in the positive direction, 11 pi over 6 is right here in quadrant 4. Now if you went 4 quadrants in the negative direction, 1, 2, 3, 4, negative 11 pi over 6 would have to end in quadrant 1. So I often think about the positive angles in the negative direction. So now, since tan of negative 11 pi over 6 is root 3 over 3, that means cotangent will be 3 over root 3. And again, maybe remember that this was originally 1 over root 3. So this is the same as root 3 over 1. And you have to be able to switch back and forth if you had multiple choice questions. Cosecant negative pi over 2. So I would think about sine of negative pi over 2. This is your axes family. Negative pi over 2, that's right at the bottom of your unit circle. Sine is which coordinate? X or y? It's your y coordinate. So sine of negative pi over 2 is negative 1. Which quadrant is that in if it's on the axes? Well, I guess technically you could say it's in quadrant 3 and quadrant 4. But it really doesn't matter for the axes family. You can sort of deal with them separately. So I know that it's going to be negative 1. So what's cosecant going to be? 1 over negative 1. The flip, which is still, right? Because if it's a negative 1 over 1, then the other one's 1 over negative 1. But it doesn't matter where that negative is. You'll get negative 1 either way. Question? No, you're just also Everybody's like, hey, it's all good. So these questions most typically come up like this on tests and quizzes. They combine what we were doing individually into 3 or 4 of them together. So what I often do is I'm going to put a little bit of space off to the side to show some work. I'm going to figure out this one first. And I'll do it in blue, so we color code it over there. So I want to find secant of 11 pi over 3. So in my head, I would first find cos of 11 pi over 3. I know that it's going to be part of my pi over 3 family, and cos of my pi over 3 family is 1/2. But 11 pi over 3 is, as a mixed fraction, 3 2/3 pi, which means it ends in quadrant 4. Because 3 would be on the negative x-axis, and then 2/3 is more than half, so it's going into quadrant 4. Because it's in quadrant 4, cos is positive in quadrant 4. I know that cos of 11 pi over 3 is 1/2. Therefore, for secant, I can write 2/1. Next, it's multiplied by cos of negative 5 pi over 4. Negative 5 pi over 4 is in quadrant 2. Again, one way that you can think of that is if you look at your unit circle and you see that positive 5 pi over 4 is in quadrant 3, if you went 3 quadrants in the negative direction, you would end up here in quadrant 2. And I already know cos of my pi over 4 family is root 2/2. But since it's in quadrant 2, cos will be negative. That's not purple. There we go. And then finally, tan of 23 pi over 6, I know it's going to be root 3/3 because it's part of my pi over 6 family. 23 pi over 6 is 3 5/6 pi, which tells me it ends in quadrant 4. Tan is negative in quadrant 4, so this will be negative root 3/3. Then how do we multiply fractions? We multiply the numerators, we multiply the denominators. Maybe you would say, hey, 2 divided by 2, that simplifies. You could do that right away. And you're just left with, well, a negative times a negative. That's going to be positive. How do I multiply radicals? Root 2 times root 3? That's root 6. And 1 times 3 on the bottom? Root 6/3. So I have another handout that practices these kind of questions. Oh, and this is, so in particular, there's 4 parts to this assignment. In particular, parts 3 and parts 4. Ooh. Okay, I think I sent 1 too many down this row, so I'll send 1 too few. So it should work out. There was, yeah, then I would be screwed up either way. too many. Oh, everybody has too many. I did that because it's so fun in the English language to say too properly in a sentence. Could you make a sentence that uses to, TWO, TOO, and TO properly with all three of those in a row? Have to work on that. I gave too many to you. Wow. Oh, it has many. I put many, that's almost, right? Too. No, I had the many in there. It's so close. Okay, we'll work on it. Sentences with two, and two, with all three words in a row, proper grammatically. What? But that's two, but it's all the same two. So the question is, okay, we're really thinking about math here. I'm sorry, guys. Got me off topic. Use this word, and this word. Sam? Two, twos, to you, two? Two? Okay. All right. We'll get back to our next part. So in grade 11, you solved equations. In grade 11, this question would have looked like this. Sine of theta equals, and then instead of negative root 3 over 2, they probably would have given you a decimal place. Sine of theta equals negative 0.866. Solve for theta between 0 and 360 degrees. So let's just go down a little bit of memory lane. Let's do it like we did in grade 11. How would we have solved this in grade 11? Well, your teacher would have said, sine is negative. According to your cast rule, sine is negative in quadrants 3 and 4. So you might have even drawn a picture of an angle in quadrant 3 and said there's another angle in quadrant 4. And the first thing you need to find is your reference angle. Your reference angle is right here and right here. And how do you find a reference angle? Well, how do you get rid of sine? You want to get theta all by itself. You do sine inverse. So your reference angle will be sine inverse. And your teacher might have said, oh, and when you find reference angles, you always do it positive. So you'd have 0.866 positive. And then from there, you would go to your calculator and you would go and you would get 60 degrees. And then your final answers for theta, well, what's 180 plus 60? You would write 240 degrees. And what's 360 minus 60? You would write 300 degrees. But in grade 11, you would need a calculator for this question. Okay? In grade 12, this is how it's going to look. You're going to say root 3 over 2 is on my unit circle. When is my y-coordinate, because it's sine? For what family do I have a y-coordinate of root 3 over 2? It's my pi over 3 family. So you already know your reference angle is your pi over 3 family. But then using your cast rule, you know it's in quadrant 3 and quadrant 4, So what is your pi over 3 family in quadrant 3? 4 pi over 3. What is your quadrant pi over 3 in quadrant 4? 5 pi over 3. And this is how we'll do it now in grade 12 without a calculator. So you can find the reference angle, which you used to have to use your calculator for. If you can recognize the value as a value on your pi plate, you get your reference angle right away. Then you just need to know what quadrants it's in to solve the rest. Watch this. I think I've got it. Using a math example. Okay. Normally, order of operations, you would add the 1 plus 3 and get 4 and then do 5 times 4. But technically, you could, just wait, almost screwed this up. There we go. Technically, you could also do this with distribution, right? But lots of students make the mistake where they just forget to multiply, right, the 5 times the 2. So if Eliza made this mistake, I would say that she forgot to multiply 2 2 2. Almost used all 3 2's. But I had the word the in there. She forgot to multiply 2 2 2. That could work, right? Right? If you forget to multiply 2 2 2. Yeah, there we go. Yes. Now we can learn some, this video I will put up online as this stuff, but I will also put in there 2 2 2. So if you search it later, you can remember, oh yeah, it's 5 years from now. This is probably what's going to happen. You're going to be like, I don't remember any math Mr. JR taught me, but I do remember these stupid things that we did. All right, second example. Cos of theta equals -1. Is -1 ever your x coordinate on your unit circle? Where? Pi. Is that the only place? Done. So this is how easy these questions become. You have to recognize the value, know from your big idea, cos is x coordinate, sine is y coordinate, and then a lot of these you can just write the answer down. This one we don't need a reference angle for. The axes family, you can just answer directly. Is tan ever 1? What family? Pi over 4. So that's our reference angle. We know it's part of our pi over 4 family. Then, tan is negative. What quadrants is tan negative in? No. Quadrant 4 and quadrant. The nice thing is this mic doesn't pick up a lot. So there's my quadrant 2, 3 pi over 4. There's my quadrant 4. And those will be our answers for tan. If you get a question that's secant, cosecant, or cotangent, the first thing you can do is you can change it. The angle doesn't change, but if secant is 2 over 1, then cos is going to be 1 over 2. Do we ever have the x coordinate to be 1 over 2? What family is that? That's your pi over 3 family. Then once around the circle, and at this point, I'm going to go back to the beginning because there was something at the beginning that's going to show up in every question, and they're going to give you the domain for which to solve a question. Now, we saw it in the first one, but we haven't talked about it in B, C, or D since. This 0 to 2 pi is once around the circle in the positive direction. Does that make sense? So it means when I get to this question here, it's my pi over 3 family. Once around the circle will include all 4 quadrants. So in my cast rule, where is cos positive? Quadrant 1 and quadrant 4. So the answer to this question will be, well, pi over 3 in quadrant 1 is pi over 3. Pi over 3 in quadrant 4 is 5 pi over 3. Tiny, tiny bit harder, but not crazy. Why is this one harder? Oh, the sign isn't by itself. How difficult would it be to do this? How did I do that? Well, if I wanted to get the sign by itself, can you see I'd have to subtract 1 to the other side? And then I'd have to divide by 2. Okay? You've done that a lot since grade 9. Is it okay that we did that all in one step? So now you have sine of theta equals negative 1/2. Sine is your x or y coordinate? Y coordinate. Is it ever 1/2? What family? Pi over 6. So then, sine is negative according to your cast rule. You should look in quadrants 3. That's 7 pi over 6. And quadrant 4, 11 pi over 6. So the reason we really memorized that unit circle is so that you could pull things off quickly, right? And the best way to be able to pull things off quickly is to practice lots. That's why I gave you those 2 worksheets earlier today, so that we can keep practicing and practicing and get to know these better. Now we go to the next level. Next level involves quadratic equations and trig functions combined. Do you remember how you solved quadratic equations? So for example, if these were x's, how did you solve this? What was the main strategy you used? Or there was another, any strategy that you used to solve quadratic equations. What was that? Factoring. Number 1 strategy is if you can factor something, that is super important. Now, do you know why? Or were you just taught this? Probably you were explained why, but it's something that people forget. So I have a little activity to show you, okay, why factoring is really important for solving this, okay? What I'm going to do is I am going to put 2 numbers in my head, and I'm going to add them together, right? Because technically, this is 2 numbers added together or subtracted. Doesn't matter. One could be positive, one could be negative. I have 2 numbers in my head. I add them together, and the answer is 0. You just have to tell me one of the numbers in my head. 17? No. Okay, try again. Sorry? Just keep guessing. 4? It's not 4. 9. No. 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 Is this going to take forever? Probably. It was 7.2. There were some close ones. Oh, yeah, sure. It would take forever. Okay? Now I'm going to change the question. Again, I'm going to tell you 2 numbers. The answer is 0. I have 2 numbers in my head. You just have to guess one of them. And this time I'm multiplying. 0. One of them, if you're multiplying and the answer is 0, one of them has to be 0. The other one was 5.87. But one of them was 0. The only way you can get an answer of 0 when you're multiplying is if one of them is 0. And this is the power of factoring. When I factor this, and here I have a common factor of x, so I take that x out, leaving me with x minus 1. I have changed it from adding to multiplying. And as soon as you change it from adding to multiplying, you have two things that are multiplied, which tells you if it multiplies to equal 0, either this one is 0 or this one is 0. And if this one is 0, well, then x has to be 0. If this one is 0, then x has to be 1. And that's the reason we factor, is because when you multiply to get 0, you know that one of them has to be 0. That's just a rule in math. You can't multiply two numbers that aren't 0 and get 0. Unless he makes like lots of mistakes. 3 times 2, 0. Right? Then it's mistakes. Okay? So now we take this grade 11 concept of factoring. Well, what did you do when you couldn't factor? Do you remember? You could complete the square. Yes. What else could you do? The quadratic formula. Right? Quadratic formula is on your formula sheet this year again. So there will be some that you cannot factor. Okay, now we move to grade 12. But instead of x squared and x, we have cos squared and cos. We have something in common. I can factor out the common factor of cos. Split it here, which means that cos of theta is equal to 0, or cos of theta is equal to 1. And then it becomes a pi plate question. Is cos ever 0? Which coordinate is that? Okay, that is my x coordinate. Cos is my x coordinate. So that's axis family. My x coordinate is 0 at pi over 2 and 3 pi over 2. But cos theta equals 1. That is where it would be 0 and 2 pi. Again, I'm going to highlight the domain here. Should be something that you check when you're done a question. The textbook is notorious for sometimes being mean. I've seen this same question in the textbook where the only difference is the domain was written like this. What's the difference? Or did I write it besides the color changing to green? And my writing looking better than a typewriter? Yes, the 2 pi is not included. So if it was the green question and you added 2 pi as an answer, you would lose marks. Is that notoriously mean, don't you think? Yes. So we have to be careful. We have to be careful for that. Sometimes the textbook does that. And then the questions that I get for some of your quizzes come directly from a textbook test generator. So just be careful of that. So if it was green, you'd have to X out the 2 pi. But since it's the black, which has the 2 pi included, you would have to include 0 and 2 pi. And if you forgot the 2 pi, you would lose marks because 2 pi was supposed to be included. So we have to be really careful with that. Okay, so all of these questions, A, B, C, and D, have from 0 to 2 pi with 0 included and 2 pi included. How did you solve something like this? So again, off to the side, think if you had to solve it with just a regular x, what would you do? Is this one you would factor? Probably not. You move the 3 over 4 over. Why would you do that if you got your x squared by itself? Yeah? And then what would you do? Square root both sides to get rid of the squared, right? So you would get x equals, and what would you get on this side? Oh. I was about to catch you on this and lose, but you caught it right away. Do you remember that when you square root both sides, that you have to remember plus or minus. And it will be the square root of this whole thing, which is the square root of the top, divided by the square root of the bottom, which will be root 3 over 2. So now we get to grade 12, and we don't have an x squared anymore. We have sine squared. So the same idea. Oh, I'll get the sine squared by itself. I'll square root both sides. I won't forget the plus or minus. And then we need to find out what our reference angle is. Root 3 over 2 on your unit circle. What family? Pi over 3. And because it's plus or minus, all four quadrants. Pi over 3, 2 pi over 3, 4 pi over 3. Oh, this is the Thanksgiving special family gathering. There we go. Everybody's invited. All four angles because of that plus or minus. If you could go back in time to yourself in grade 10, when you started to factor, you would probably tell yourself in grade 12, please get to work, because we are going to use this so much in grade 11 and grade 12 that, and in fact, do any of you have a period 3 spare? Could you come to my grade 10s are just starting to do factoring. Can you come and tell them how important it is for the rest of their math for grade 11 and 12? Or you want to come back and be like, I need to learn this. Okay, I needed to come back to grade 10 and I watch it again because it's so important. So factoring when you have all three of them. Yeah, like this is just like factoring this, right? Okay. So how do we factor this? Now, you've learned there's a bunch of different techniques that are taught in grade 10, and they're all great, but what I find is that by the time you get to grade 12, you have forgotten them. So most of factoring in grade 12 can be brought back to a simple concept of grade 9 and grade 10 is if you know how to multiply two things. So for example, I'm going to pick a totally, this is not the answer. Let's just do 3x plus 2 and x minus 5. How do I make it pause like that? That's the computer not being smart. Because I know it's supposed to work. So it will eventually work. Now, if you had this and you had to multiply it out, in grade 10, you learned that you had to distribute everything. This times this times this times this times this. And something interesting happened is 3x times x, that gave you 3x squared. And then 3x times minus 5, that gave you minus 15x. And then 2 times x is plus 2x. And then 2 times negative 5 is negative 10. Right? And I did the ones in the middle in purple because they end up being like terms. And so this becomes 3x squared minus 13x minus 10. Maybe I'll keep the minus 13x in purple. Maybe not. There we go. Now, understanding that gives you a hint for how to factor. First of all, the easy ones that are a hint are the first one and the last one. Okay? Because nothing had to get simplified. I know that my first ones have to give me 3x squared. So when factoring 2x squared minus 3x plus 1, if I know that my first ones have to give me 2x squared, do you realize there's only one option? How can you get 2x squared? 2x and x. Only one option. Then, your last one is your next hint. And this one is, the one that I gave you is really easy. How do you get 1? There's only one option for that. 1 and 1. And then the last thing I like to do if I'm using this technique to factor is I just have to find out what the signs are going to be in the middle. Positive, negative, both positive. What's it going to be? And this is where the purple part comes in. I know that the outside and the inside, they have to make negative 3x. So, is it pretty obvious that they both have to be negative? If I make them both negative, do I get the negative 3x? If I make them both negative, is my last number still plus 1? Yes. And so I find that you've probably forgotten other factoring techniques. If you still remember them and love to use them, perfect. But you can, now that you're in grade 12, probably work it out backwards pretty easily. And the nice thing about this technique of working it out backwards is you should always force yourself to quickly multiply it out again. Like, does 2x times that give me 2x squared? Yes. Do my last ones give me the last ones? Do the outside and the inside one give me my middle ones? And then I know that I'm right because I've double checked it. So now we get to, right? This one would be harder, wouldn't it? The minus 10, right? If you were factoring this one, I mean, we already know the answer. Why is this one a little bit harder? Because the last one, 10, could be 1 and 10 or 2 and 5. So we have some options there. Secondly, the first one, though, only gives you one option. It has to be 3x and x. And now we need our outside and our inside needs to make negative 13. I hope right away that you can see that 10 and 1 is going to be bad. Like even if I put the 10 here and the 1 here, that makes 13. If I put the 10 here, that'll make 30, and the 1 here, that doesn't ever add or subtract to make 13. But if I put a 2 and a 5, it does. And you see that you have to put the 5 here and the 2 here, because if I put the 5 here and the 2 here, then my outside is 6 and my inside is 5. That doesn't make negative 13. But if I put my 5 here and my 2 here, I have 15 and 2. And to get a negative 13, my 15 would have to be negative, and my 2 would have to be positive. I mean, we knew that that was what it was because we started with it, but it's showing the idea of how you work backwards to factor. And now we're going to take that idea and we're going to get a bunch, but now instead of x squareds, we'll have trig functions squared. So again, same idea. I'm going to set up my brackets. Equal to 0. What is the only option to get 2 sine squared? It'd have to be a 2 sine and a 1 sine. Go to my last one. The only option to get 1. This is, like, to me, this is the easiest factoring one in the world because we had no other options and we're almost done factoring. The tricky part is thinking about the outside and the inside. And should they be, what should the signs be? And they both need to be negative for that to work. Wow. So now that we've factored it, we can split it right here. Maybe I should use a different color. This one seems to be out of ink. We'll try black. Okay, so I'll split it right here. Can you see that if this is 2 sine theta minus 1, if this, oh, beautiful. If this was equal to 0, then sine of theta would equal 1/2. And if this one was equal to 0, then sine of theta would equal 1. And we're back to our unit circle, and our pi plate is a half on your pi plate for sine. What family is that? That'll be our reference angle, pi over 6. Since sine is positive a half, that means our angle will be in quadrant 1 and quadrant 2. Second one, is your y-coordinate ever 1? It's axis family, right? So you don't have to do a reference angle. You can just go and write the answer down. So you are going to factor a lot this year. Does this factoring technique make sense to you? How it's just like that's all factoring is the opposite of multiplying. So if you know how to multiply, you have to use the strategies that showed up in multiplying to work backwards to factor. If you get stuck, if you ever like, ooh, I don't like to factor this one because it's too much, you can always use the quadratic formula. You can plug it in, that negative b plus or minus square root of b squared minus 4ac over 2a, that one, right on the tip of your tongue. You can always use it, it's on your formula sheet. But if you get good at factoring, factoring will be faster. So we go to question part D. And this one, I have a hint in your notes. You don't get the hint on the test. Okay, so we have to know how to do these ones, but we'll do a lot of these. Right now, you can't solve it because it has a sine and a cos, right? That's like asking you to solve this. Solve, oh my goodness, negative 3y minus x squared minus 3 equals 0. You can't solve that because you have an x and a y. Do you remember solving systems of equations in grade 11? Where you had two things you didn't know, then you need how many equations in order to solve it? You needed 2 equations. And your teacher might have called it, oh, we have 2 equations with 2 unknowns. That sounds familiar. And then you could use either substitution or elimination. Remember those techniques to solve it? Well, this is basically one of those systems questions. We have 2 things that we don't know, a sine theta and a cos theta. And the hint, use the identity, use the big idea. Remember this big idea that sine squared theta plus cos squared theta is always equal to 1. From that big idea, you could rearrange things for substitution. If I wanted to get cos squared by itself, can you see that it would equal 1 minus sine squared? And if I wanted to get sine squared by itself, it would equal to 1 minus cos squared. What that lets me do is I can rewrite my original equation, negative 3 sine theta minus 3 equals 0, but instead of the cos squared, what would I write instead? Cos squared can be changed to 1 minus sine squared. I put it in brackets because you were subtracting a cos squared. So now you'd have to subtract all of this, which means that this negative would get distributed to both of those. And if it did, can you see that you would get a positive sine squared? You have still a minus 3 sine theta. And then you have a minus 1 minus 3, which would give you minus 4. Everybody okay with that? The negative times the negative gives me a positive sine squared. I wrote that first because it's squared. Then I still have the minus 3 sine theta from there. I just wrote that second so that it's in the order that's nice for factoring. Again, using the same technique for factoring. Only way to get sine squared would be sine theta and sine theta. Ooh, 4 you have options. 2 and 2 or 1 and 4. But you need your outside and your inside to make minus 3. Can you see that 2 and 2 is not going to work? So it has to be 4 and 1 to multiply. So if we go 4 and 1, does it matter if I write 4 and 1 or 1 and 4? In this case, no. Sometimes it does if this like had a 2 sine theta, then the order matters. But in this case, you could write 1 and 4 or 4 and 1. We need to get a minus 3. The 4 has to be negative, so the inside's negative 4 sine theta, and the 1 positive. I do a quick check. Does my last one still work? Okay. And then split it here. If this one is 0, then sine of theta would equal 4. If this one is 0, then sine of theta would equal negative 1. Are either of those on your unit circle for a y coordinate? Yes, this one, right? When is your y negative 1? Right? 3 pi over 2. And the reason we're not saying negative pi over 2 here is because we're still working with the, oh, I hit a button. We're still working with 0 to 2 pi. So negative pi over 2 doesn't fit in here. Four, though, is not on your unit circle. If something is not on your unit circle, usually that means you have to use a calculator. But this one you can do without a calculator because can you ever have the opposite over hypotenuse be 4 over 1? Not possible. Okay. So get working on those worksheets. I have to remember to save this as 222.